Students, all of you, good evening. Welcome to the session. Continuation of circuit theory, that is network theory concepts. I am discussing the chapter 1, that is fundamentals of electrical circuits. With respect to chapter 1, I am starting lecture 16. In the previous session that I solved some models of questions with respect to nodal analysis. I have to see the concept of supernode analysis. Why do you go for the supernode analysis? Then after that, you will see some practice questions with respect to supernode analysis. Then we will start the mesh analysis concept. To explain supernode analysis, let's consider one example. Why the supernode analysis? What exact concept involved in the supernode analysis? For that, let's consider one example. If you try to apply the nodal analysis for this circuit, students, then what is the nodal analysis? The current is entering at a V1 node, that is minus 9 amperes, plus V1 by 1 by 2, plus V1 minus V2 by what is the resistance in this path? Is there any resistance? Let this is the one voltage source. The value of that voltage is equal to, just a minute, I'm giving that voltage also. Let us assume that this is the 5 volts. This is 5 volts. If you apply V1 minus V2, what is the resistance in this path? 0. Then it is equal to 0. It is not valid because we are getting infinity. It is not valid. That is, directly by using nodal analysis, we can't solve this type of nodes. What is the supernode here? Between two nodes, if any ideal voltage source is present, this is ideal voltage source. Because what is the resistance connected in series with this voltage source? 0. For any voltage source, if the internal resistance is 0, then we can say that is ideal voltage source. Then to solve this type of models, then you go for the concept of supernode analysis. Then how to apply the concept of supernode analysis? That I have to discuss. First, we will see this statement. Since there is an ideal voltage source between two nodes, current through an ideal voltage source can be any value. It's just like it's infinity, na? It's any value. We cannot write the node equations directly. Here, the concept of supernode is to be used. That is, by combining both the nodes. Instead of writing the nodal equations at V1 and V2 separately, combinedly for both the nodes, we have to write the node equation. That is, by combining, we have to use the one nodal equation. By combining both the nodes, we need to write a single equation. But you have to solve two unknowns now. V1 is unknown, V2 is unknown. By combining these two nodes, you have to write one nodal equation. And inside, within the supernode, you have to apply KVL. Then you can get one more equation. Then by solving these two equations, we can get the two unknowns. This is the concept. Clear, students? Why do you go for the supernode analysis? This is the reason. Between any two nodes, if any ideal voltage source is connected, ideal voltage source means the internal resistance of that voltage source is. Then, if any ideal voltage source is connected, we know that the current through the ideal voltage source is any value. Because here we are getting infinite. That's why, separately by applying nodal analysis at V1, nodal analysis at V2, we can't solve. For that, what you can do? By combining these two nodes, you can write one equation. And by applying the KVL within this loop, within this supernode, you can write one more equation. Then by solving those two, we can get the two unknowns. But here we have one doubt. Sir, how we combine these two nodes, sir? How to combine these two nodes? What the concept is involved to combine these nodes? That point also I will give. Later I will give. First point to remember, why to go for the supernode analysis. Then how to solve this model of question, I will explain. Before that, these points you have to remember. When either node of a voltage source is not connected to the reference, the source is called floating voltage source. Either node of the voltage source is not connected to the reference, the source is called a floating voltage source. If you take any, this is the reference or zero potential node. If it is not connected to the reference node, then that is called a floating voltage source. When a floating dependent or independent, it may be dependent is present or independent is present, is given with respect to given reference node, a direct application of KCL, either terminal is not possible because current in the branch with the voltage source is not known. Because it is any value. Infinite current we are getting now. We are getting infinite current. That's why it is any value. It may be dependent source is given or independent source is given, directly you don't apply nodal analysis. Not possible, because current in branch with voltage source, only with voltage source, is not known. To solve such problems, a supernode analysis is used. To solve such problems, we have to apply the supernode. Actually, this voltage source is called floating voltage source. It is not connected to the reference. That's why it is called floating voltage source. If any floating voltage source, this floating voltage source may be dependent voltage source or it may be independent voltage source. But say, for example, friends, if voltage source, if there is any resistance is present, then no need to apply supernode analysis. Then you can write nodal equation at V1, you can write nodal equation at V2, then you can solve. But point to remember, friends, even normal condition also, without floating voltage source also, we can apply supernode analysis. We can get the same answer. But no need to go for that much of lengthy procedure. Because if normal case, we can easily solve just by applying nodal analysis at V1 and V2. But in this case, surely you have to apply the supernode analysis. If resistance is not present, you have to apply the supernode analysis. If this resistance is present, you apply the supernode analysis. Even normal nodal analysis also, we can get the same answer. That is, supernode means it is not a separate node, sir. This is the node itself, but there is ideal voltage source between the 2 points, between the 2 nodes. Then only you have to apply the supernode analysis. Supernode analysis, normal condition also you can apply. With floating voltage source also you can apply. You can get same answer. But with floating voltage source condition, we don't apply normal analysis. But supernode analysis, we can apply normal condition, even floating voltage source condition. Understood? Okay. For this type of case only, go for the supernode. Now, you have to see one problem, how to solve the supernode, by applying supernode analysis, how to solve this problem. Like this example, you have to find the V1 and V2. In this, you have to find what is V1, what is V2. This given voltage is, this is 5 volts. How much it is given? This is 5 volts. This is 5 volts. Then between V1 and V2, between V1 and V2, ideal voltage source is present. Ideal voltage source is present. Source is present. Hence, this problem is solved. This problem is solved by using supernode analysis concept. Supernode analysis concept. This problem is solved by using supernode analysis concept. I told already, in supernode analysis, for these 2 nodes combinedly, you are writing one equation. Combinedly, you are writing the one equation. I am writing this -9 is entering, plus V1 by 2, V1 by 1 by 2, plus V2 by 1 by 6, plus V2 by 1 by 6. This current is entering now, -4 equal to 0. -4 equal to 0. Combine. Don't write this one. V1 minus V2 by 0. That we are not writing. That is, for both the nodes combinedly, we are writing one equation. The current is entering now. It's a -9. V1 by 1 by 2. V2 by 1 by 6. This current is entering now. This is -4. Then you have to simplify this. This is -9 plus 2V1 plus 6V2 -4 equal to 0. That is 2V1. 2V1 plus 6V2 is equal to 30. That this is equation equal to 30. But point to remember, in supernode, inside supernode, KVL is applied. This is taken as a supernode. That is inside supernode. Inside supernode, KVL is applied. Sir, what is the supernode? Still you have doubt. If any floating voltage source is present between 2 nodes, or an ideal voltage source is present between two nodes, then it is taken as a supernode concept. It is taken as a supernode concept. Inside supernode, that is inside this node, you have to apply KVL. Inside supernode, KVL is applied. KVL is applied. Now, you have to apply KVL as source. Inside the supernode, you have to apply the KVL. Then this you have to take the plus minus. This is plus minus. And you have to take this is also plus minus. This is also you have to take this is plus minus. This is also plus minus. Take this is plus minus. This also plus minus. Now, what is the voltage across this one? This is V2. What is the voltage across this? V1. This is node now. This is V1. This is voltage now V2. This is plus minus V2. Now you have to apply KVL here. We can get one more equation. This is the concept. Concept very simple, sir. Then if you apply KVL, negative to positive, then inside SuperNode, KVL is applied. KVL is applied. Inside SuperNode, KVL is applied. Negative to positive, positive, plus 5. Positive to negative, negative, minus V2. Negative to positive, positive, plus V equal to 0. Then from this, how to write? V1 minus V2. Shall I write like this, friends? Negative to positive. This is positive. How to write? Plus 5. Positive to negative. Positive to negative. This you write KVL now. Minus V2. Positive to negative. Minus V2. Negative to positive plus V. Then from this, what is V2 equal to? V1 plus 5. V1 plus 5. V2 equal to V1 plus 5. Then from this, what is V1 minus V2? V1 minus V2 equal to minus 5. Let this is equation 2. Now solve 1 and 2 by solving 1 and 2. By solving 1 and 2. Solving. Can anybody tell what is V1 value, what is V2 value? Come on, do it. Equation solving, that you know. That is the fundamentals. Can anybody answer? Come on. Small correction here. You have to take this one. Small correction. Actually, this is plus minus. I given minus plus. This is plus minus. This correct. This is plus minus. Even by taking minus plus also you can get answer. But actually, I solve this problem. This plus minus. Take this is plus minus, and this is a plus minus. It's repeated. 1 by 2, 1 by 6, by 6, 9, 4. That is correct. Just a minute. 1 by 2, 1 by 6, 9, 4. Yes, that is a plus minus. This is plus minus. Please correct it. If you do the plus minus, then what you can get? Just a minute. This is minus 5. Minus V2 plus. That is V1 minus V2 equal to 5. V1 minus V2 equal to 5. Please correct it. Yeah. If you solve by taking minus plus, no problem. That also we can get some other answer. V1 minus V2 equal to 5. This is 2. And this is 1, this is 2. Now you tell the answer. Can you tell now? Please write. Because actually I solved these two. By considering plus minus, I solved. That's why I'm changing this polarity. No problem. By taking minus plus, you solve means you can get different answer. By taking plus minus, if you solve means you can get another answer. 2v1 plus 6v2 equal 13. v1 minus v2 equal to 5 students. Now you tell the answer. What is the answer you got? I got this 5.375. v1 equal to 5.375. And v2 equal to 0.375. Is it correct? Anybody? I got v1 equal to 5.375 volts and v2 equal to 0.375 volts. But polarity is with this assumption only, plus minus. Actually, they given plus minus in the problem. This is plus minus. It's also plus minus. It's a plus minus. Is it correct? Please check the answers. 5.375, 0.37. Yes. Can anybody answer this question? This is 2 volts. This is 2 amperes, 5 amperes, V1, V2. Can you solve for V1 and V2? Again, this is applying SuperNode analysis. Apply the SuperNode analysis. It is a minus plus. This is a minus plus. It is a minus plus 2 volts. If you apply SuperNode analysis, 2 amperes is entering, that is minus 2 ampere plus V1 by 2. V1 by 2 plus V2 by 4. And this is minus 5 ampere is equal to 0. Can you simplify this? V1 by 2 plus V2 by 4 is equal to 7. V1 by 2 plus V2 by 4 is equal to 7. Then 2V1 plus V2. 2V1 plus V2 equal to 7. Let this is equation. Then take a inside you have to apply the KVL. Inside you have to apply KVL. This is plus minus V1 plus minus V2. plus minus V2. For SuperNode, you apply the KVL. KVL. That is positive to negative. So negative to positive, positive, negative to positive, positive, positive to negative, negative, negative to positive, positive. Then V1 minus V2 equal to minus 2. This is the equation 2. Then by solving 1 and 2. Now, can anybody answer this? By solving 1 and 2. Come on, students, wait. 2V1 plus V2 equal to 7. V1 minus V2 equal to minus 2. Come on, do it. What is V1 you got? What is V2 you got? 2V1 plus V2, is it a 7 or 28? I think it is a 28. Na? LCM is 4 now. You bring this 4 this side. 4 into 7, 28. It's a 28. Please correct, sir. It's a 28 now. See the calculation. LCM is 4, sir. It's a 2V1 plus V2. 4 into 7, 28. Now you tell the answer. This plus V2 minus V2 cancel. 28 minus 2, 26. 26 by 3. What is V1 you got? I think you got the V1 is 26 by 3. Is it correct? 26 by 3. Approximately 8.667 volts. 8.667 volts. Yes, very good. 8.667 volts. What is the V2 you got? V2. V2. This 10.667 volts. 10, just simple. Substitute V1 here. You get V2. 10.667 volts. Yeah, this is the V1 and V2. So concept very simple. Just you see when you apply the SuperNode analysis. Then you have to apply the SuperNode analysis. Clear? Next. V1 is 8.667. V2 is 10.667 volts. Can anybody solve this one? Find V1 and V2. This plus minus, this voltage is 36 volts. This is 36 volts. This is given in the problem. Can anybody try it? Come on, do it. Calculate V1 and V2. Everybody, please do the problem now itself. If any doubt you ask, I will clarify. Calculate V1 and V2. Apply nodal analysis by combining V1 and V2. This is V1, but it is a minus plus. Please see the polarity. If it is a plus minus, it is a plus minus V1 minus 12. It is a minus plus na V1 minus of, this is minus plus na minus 12 by 4 plus V1 by 6 plus V2 by 12 plus V2 minus 24, because this is plus minus polarity. V2 minus 24 by 3 equal to 0. Correct? Now we have to simplify this. That is V1 plus 12 by 4 plus V1 by 6, V2 by 12, that is V2 minus 24 by 3 is equal to 0. That is V1 by 4, 12 by 4, 3, plus V1 by 6, plus V2 by 12, V2 by 3, minus 8 equal to 0. Yes, you have to simplify this, but the value you can get students. Come on, do it. If you simplify this, I am getting V1 plus V2, V1 plus V2 equal to 12. V1 plus V2 equal to 12. Is it correct? Do simplification. I got V1 plus V2 equal to 12. Is it correct? Come on. Response, sir. Very fast you have to do the calculations. Next. Now, this is SuperNode analysis. Plus minus V2, plus minus V1. Apply KVL here. Apply KVL. Positive to negative. Minus 36. Minus V2 plus V1 equal to 0. Then V1 minus V2 equal to 36. What is V1 plus V2? V1 plus V2 equal to 12. Solve these two equations first. By solving these two equations. Solve these two equations. 2V1 equal to 48. Then V1 equal to 24. V1 equal to 24. If V1 equal to 24, then what is the V2 equal? If V1 equal to 24, what is the V2 equal? Minus 12. Is it correct? Please check it. Very good. Thank you. This equation is correct. Are you tried this? Simplified or not? Yes. V1 equal 24, V2 equal to minus 12 volts. Next. See the one more question. Can you try this? Come on, do it. This is 0.5. I'm asking one question, friends. Is it a supernode? Is it a supernode? Anybody? Is it a supernode?
Yes, sir.
No, because there is resistance is there now. Resist ideal voltage source. It may be dependent source or independent source, but it is ideal. Then only supernode concept. Otherwise, not required supernode. But even you apply supernode, we can get answer here. Even you apply supernode, sir, we can get the answer, but not required. Again, you have to apply KVL. All this not required. That's why directly go for the normal nodal analysis only. It is not supernode. It is not supernode. Supernode because of resistance. Resistance in series with source. In series with voltage source. In series with voltage source. Voltage source. Then calculate V1 and V2 source. Then first, at node 1. At node 1 source. Then if you apply nodal analysis at node 1, this 2 ampere is entering. Minus 2. Yes. V1 minus 20 by 10 plus V1 minus this V1 minus this drop is there now. Positive to negative. Positive to negative means negative. Minus 0.5 V1. So this source voltage 0.5 V1. Positive to negative now. Negative. This is V2. This total is one wire only. This total is V2 only. This is minus V2. Minus V2 by resistance is not 0. Resistance is 5. Concentrate. If the dependent source is present, how we are applying? Equal to 0. Then you have to simplify this. You have to simplify this. This is minus 2 plus V1 by 10 minus 2 plus V1 by 5 minus 0.1 V1 minus V2 by 5 equal to 0. Equal to 0. Then V1 by 10 plus V1 by 5 minus 0. V1 minus V2 by 5 is equal to 4. Equal to 4. Then what is the LCM here? What is the LCM? If you take the 10 is LCM, then V1 plus 2V1 minus V1 minus V1 minus 2V2 equal to 4. Then from this you simplify this, plus V1 minus V1 cancel, 2V1 minus 2V2 equal to 40. Then from this what is V1 minus V2? V1 minus V2 equal to 20. Let this is relation 1. Now apply nodal analysis at node 2. At node 2 students. If you apply nodal analysis at node 2, then you write V2 by 2, V2 by 2. Current is entering now, minus 5. V2 minus 30 by 10 plus this one. V2 minus, here negative to positive now, this side. Negative to, from V2 is reference now, negative to positive. V2 plus 0.5 V1. Negative to positive means positive. V2 plus 0.5 V1 minus V1 by how much resistance? 5 equal to 0. If you apply the nodal analysis at 1, we are moving like this. Positive to negative minus 0.5. If you apply nodal analysis 2, we are moving like this. Negative to positive, positive. Yes, friends. V2 by minus V2 by 2 minus 5. V2 minus 30 by 10. V2 plus 0.5 V1 minus V1 by 5 equal to 0. By simplifying this, we can get directly I'm writing do this minus V1 plus 8 V2 equal to 80. That this is equation 2. This is 1 and this is 2. By solving 1 and 2 students. Mathematical calculation is important by solving 1 and 2. Now tell the answer what is V1 you got, what is V2 you got. By solving 1 and 2, now tell the answer what is the U1, what is V1 you got and what is the V2 you got. I'm expecting answer from you. I got V1 equal to 34.28 volts. Is it correct? Anybody? 34.28 volts. V2 equal to 14.3 volts. V2 equal to 14.3 volts. V1 equal to 34.28 volts. V2 equal to 14.3 volts. All of you got same answer? Thank you. Next. So the one more problem. Can anybody answer this? In the network shown in figure, the value of Vx would be dash. You have to calculate the what is the value of Vx. In this network, you have to calculate the what is the value of Vx. Yes. Yes, friends. Let assume that how to answer this question. Let I'm taking this is the reference node. I'm taking this is the reference node. The reference node is zero potential. If it is a zero potential, if it is a zero potential, friends, taking this is the reference node. But you have the doubt, sir, why not this node? You take this is the node. Yes, by taking this also you can get same answer. But if you take here, we can easily get the answer. By taking here also how to get, I will explain. Any node, any one node is taken as a reference. Okay. Now I'm taking this as a reference. This is Vx. Vx minus 0. Vx minus 0 is Vx. That's why it is a Vx. Correct? Because it is a reference node. The reference node potential equal to 0 volts. Then Vx minus 0 equal to Vx. Now apply the nodal analysis, students. You have to find Vx now. Then if you apply nodal analysis, Vx by 1, Vx minus 6 by 1, Vx minus 6 by 1. This 2 Vx current is leaving. 2 Vx current is leaving means plus 2 Vx. 2 Vx current is leaving means that is plus 2 Vx. Next. This is Vx. This is Vx now. This is Vx and this is minus 4. Minus of minus plus. Vx plus 4 by this is 2. Vx plus 4 by 2. Vx minus of minus here. If it is a plus minus, Vx minus. If it is a plus minus, it is a plus minus now. Vx minus 6. But it is a minus plus now. That's why minus of minus. Then solve this. Vx plus Vx minus 6 plus 2Vx plus Vx by 2 plus 2 equal to 0. Vx plus Vx, 2Vx, 4Vx, 4Vx plus Vx by 2 is equal to minus 6 plus 2 minus 4 is equal to 4. This is 8Vx plus 9Vx. 9Vx by 2 equal to 4. From this, what is Vx equal to? 8 by 9 volts. See the concept. Vx equal to 8 by 9 volts. That is option B is the right answer. Just by seeing the circuit, it is appearing just like a very difficult, just like a complex circuit. But see, if you take this is the supernode, how easy this problem? If it is a supernode, this is Vx. This is Vx minus 0. This potential is Vx. But you have the doubt, sir. Why you taken not a supernode, sir? If reference node. If you take this is the supernode, this is the reference node. If you take the reference node, how easy this problem? But you have the doubt here, sir. Why you taken reference node here? You take this is the reference. If you take by taking the reference node here, then also you solve. We can get same answer. Sir, we will check it. This is okay. But by taking this is the reference node only, we can get easily problem. Just sir, how you can get idea? You have to take this is the reference node, then only you can get easily. That I told now. Network theory concept. If you have to become very strong, more number of questions you have to practice. After listening the class, if you have the time, you saw the previous gate questions, ESC questions. Still time is there. Alexander Sadiku. So many questions are there. Take one of the standard textbook. That is network theory. Alexander Sadiku or Heath and Kim. Any one book you take. Not both required. Better to Alexander Sadiku you take. Then better to solve. There is some solved questions also. That also you have to try. Then you get more confidence. Okay. See now same problem I'm explaining like this. voltage. Okay. Now, when I take this is the reference node. This is the reference. If it is a reference node, you see answer. What is the answer? Now I'm asking one question. If it is a reference node, what is this potential? Now it is not equal to Vx. Why? Because it is not a zero potential. Once it is not a zero potential, because this 4-volt source is connected here. If 4-volt source is not present, then it is a Vx. No doubt at all. It is a Vx. If this source is not present, if it is like this, then it is a Vx. But here 4-volt source is present. Because of that reason, it is not a Vx now. If it is a zero potential, it is a zero potential, then only it is a Vx. Now it is not a Vx. Let's assume that this is some potential V1. I taken that voltage. Let this is the V1 voltage. Let that is the V1. Now apply the nodal analysis. V1 minus 4. You have taken. This is V1. This is V1. I am taking this is V1. That is you have taken V1 minus 4 by, what is the resistance in this path? 2 ohms. V1 minus 4 by 2. Next, V1 minus 6 positive to negative. Negative. Again, this also connected. This is the, this total is node. From reference node we are applying up to reference. V1 minus 6 positive to negative. Negative. Minus 4 by, what the resistance? 1. The resistance is 1. 2 Vx current is leaving now, plus 2 Vx. Plus 2 Vx. Plus 2 Vx. Clear? V1 minus 6. V1 minus 6 minus 4 by 1. This V1 minus 4 by, just a minute, I have to give one observation here. Just a minute. It's not V1 minus 4. This is V1 by 2 only. It is a zero potential. It is a zero potential. V1 by 2 only. Why I am writing like this? This is V1 by 2. This one, it is a zero, up to zero potential now. This is up to this. This source is up to like this. In this path, source is added. But this path, here only zero potential. That is V1 by 2. This V1 minus 6 minus 4 by 2 plus 2x. But what about this here? What about this potential source? What is Vx? How to calculate Vx? You tell me. What is Vx?
So Vx and V1 will be same.
Vx and V1 is same. How? See, this is plus minus 4. Na? This is 4 volts. Is it correct? Sir, this is plus minus 4. Na? It is a zero potential. Means what is this voltage?
Yes, sir.
It's 4 volts or not? If it is a 4 volts, if it is a 4 volts, if it is a 4 volts, now, if it is a 4 volts, now we can apply like this now. V1 minus 4. V1 minus 4 by
By 1. V1 minus 4 by 1.
this is correct. Is equal to 0. Clear or not? But how to calculate Vx? Later on I will tell. First to calculate V1. Once you know the V1, calculation of Vx is very easy. How to calculate Vx? I will. First you calculate this V1. Solve this. Or you can write the V1 in terms of Vx. Directly you can get the Vx. You have to write the V1 in terms of Vx. How to write V1 in terms of Vx? Shall I write like this? This is 4 volts now. This is 4 volts. This is 4 volts. If you apply loop here, KVL, V1 minus Vx, positive to negative, minus Vx, up to this one. V1 minus Vx, positive to negative, minus 4, equal to 0. What is V1 equal to 4 plus Vx now? V1 equal to 4 plus Vx or not? You take this path, sir, up to this. V1, positive to negative, minus Vx. This is positive to negative, minus 4, equal to 0. V1 equal to. Then you substitute here. 4 plus Vx by 2. 4 plus Vx minus 6 minus 4 by 2 plus 2 Vx. V1 equal to 4 plus Vx minus 4 by 1 equal to 0. Now we calculate what is Vx. Come on, do it. This is 2 plus Vx by 2 plus 2 plus Vx by 2 minus 5 plus 2Vx plus Vx equals 0. Vx plus 2Vx, 3Vx. This Vx by 2, Vx by 2. How much you got? V1 equal to 4 plus Vx. You substitute is that item. That is 2 plus Vx by 2 plus 2. That 4 plus Vx I substituted. Minus 6 minus 4 minus 5. That is 2 plus Vx by 2. This is 2Vx. 2Vx. V1 equal to 4 plus Vx minus 4. That is Vx. Are you getting same answer or not? 3Vx. Please check it. Is there any calculations or not? 3Vx. 4Vx. Something. V1 minus 4 by 1. V1 minus 6 minus 4 by 1. This is 2Vx. It's V1 by 2. 1 equal x. This is Vx. Vx minus 6 by 1. Sir, this is not 2, na? This is 1, na? Please. This is 1. I have done 1, 2. This is 1. Correct? This is 1, sir. Please. Correct. Calculations are perfect. Then 2 plus Vx by 2 plus 4 minus 4 cancel. That is Vx minus 6. Vx minus 6. This is plus 2Vx plus 2Vx. Then this is 4 cancel plus Vx equal to 0. Vx plus 3Vx, 4Vx. 4Vx plus Vx by 2 is equal to how much, sir? This is minus 6 plus 2 minus 4. This is 4. 8Vx plus 9Vx. 9Vx by 2 equal to 4. Then Vx equal to 8 by 9. I got same answer or not? Please check it. Are you getting same answer or not, sir? 8 by 9. That is the answer. That means you take any node, is the reference node, finally you get same answer. But applying the concept is very important. See, here you get idea. Whenever I taken this is the reference node, here the potential is not 0. Here the potential is 4 volts. Now this potential is not V1. Sorry, this potential is not Vx. That is different voltage. That's why I taken V. This potential is 4 plus Vx. This potential is 4 plus Vx. Because this is minus plus minus plus. Adding now. Minus plus minus plus adding. That's why 4 plus Vx. That is changing. Clear, students? That you have to concentrate. This about the super node analysis and nodal analysis. Maximum these models are enough. With this knowledge, you try to solve the previous GATE and ESE questions. And this question I am giving homework for you practice. What is the voltmeter reading and ammeter readings you have to calculate. Apply the nodal analysis, calculate voltmeter reading and ammeter reading. Let this voltage is V1, this voltage is V2. These answers are, I am giving answers also. Voltmeter, if you have any doubt, please share your doubt in my Telegram channel. I will give the detailed solution. The voltmeter reading equal to, for this case, 2.1178 volts you can get. 78 volts. Ammeter reading equal to 0.434 amperes. 0.434 amperes. 434 amperes. Yeah, this you try for practice. That is homework. And this question also you try for homework. This is 1 volt. What is this concept you can apply? Normal nodal analysis or super node? Which concept you have to apply, sir? This is a super node concept. And this problem also you have. For this answers I given here. V1 equal to 1.5 volt. V2
So
equal
for
to
example 7, can we solve this by nodal analysis also?
example 7. Yeah, you solve nodal analysis also. Sorry, it's a super node, sir. Don't apply nodal analysis. I am telling that if there is no super node concept, then that type of problems you can solve normal nodal analysis and super node analysis. If there is a concept of super node, you have to solve only by applying the super node. Here there is no any resistance in series with voltage source now.
No, sir.
That's why it is a super node. Super node concept you have to solve only with super node. Normal, if there is no super node, you can apply super node concept or normal nodal analysis also. You can get same answer. Clear?
Yes, sir.
Next. This also you try for homework for practice. This is a DRDO question. Right. It is a nodal analysis concept. The next concept is mesh analysis. The mesh analysis is that KVL plus Ohm's law. I told already, mesh analysis applied only for planar network. For non-planar network, we don't apply mesh analysis. But for non-planar network, you can apply nodal analysis and mesh. Both are applicable. But mesh analysis is applicable only for planar. We know that in mesh analysis, how many number of KVL equations are required? KVL plus Ohm's law now. Number of KVL equations. Can anybody? Number of KVL equations.
The two KVL equations.
The number of KVL equations equal to B minus N plus 1. Number of KCL equations are NP minus 1. Number of KVL equations equal to B minus N plus 1. If you have to solve any problem using mesh analysis, how many number of KVL equations are required? That is B minus N plus 1. Then what are the steps you have to follow? Check if circuit is planar. If necessary, redraw the network without crossing the elements. I told already. In a two-dimensional plane, without any crossings, if you draw the network, then it is a planar. Identify the independent meshes. Third step is define mesh currents. For consistency, select clockwise direction for each of the mesh currents. But this is not required. You take any direction, each mesh, but follow the one direction. In one mesh, I taken the direction is clockwise. In all the meshes, you have to take the clockwise. In one mesh, I taken the current is anti-clockwise. You have to take all the meshes is anti-clockwise. Follow one direction. Either you take clockwise or anti-clockwise. The current directions. But not always clockwise. You take anti-clockwise, you follow, or clockwise, you follow. Final answers you can get same. Apply KVL to each mesh and write their linear voltage equations. Solve the linear equations to obtain mesh currents. If voltage across current source to be calculated, write KVL around mesh containing the current source. If any voltage across current source is required, you have to write the KVL around mesh containing. How to solve? You'll see some models, then you get idea all these steps. Now, this problem, a lengthy problem I taken, but just this is not for to get the solution for this one. Just how to apply to understand how to apply the mesh analysis only, I taken this problem. Now, here how many independent meshes are there? Independent loops are nothing but meshes. How many independent loops are there? You have to take the how many independent loops are? There is a 3 independent loops. Then you take the 3 currents. Let this is I'm taking the clockwise direction. Let this current I taken as a I1, and this current I taken as a I2, and this current I taken as a I3. This is I3. Clear? Then according to current direction, see for example, this is loop 1. I taken this is loop 2. This is loop 3. First, I'm writing for loop 1. Loop 1. If you write the loop 1, this is current is flowing like this. This is the current direction I take. This is plus minus. With respect to loop 1, I'm telling plus minus. Plus minus, positive to negative, negative. Negative. 50 into, this is I1. Opposite which current is I3. That is I1 minus I3. I'm taking loop 1 means you follow the loop 1 current direction. Loop 1 current direction. Loop 1 current direction is like this now, positive to negative. Wherever the current is entering, that is plus. Then there is a minus. Positive to negative, negative. Minus 50, I1 minus I3. Next. The current direction is like this now, with respect to loop 1, sir. I'm telling that loop 1 current direction. Then positive to negative, negative. Minus 100, I1. Opposite which current is coming? I2. Minus I2. Next. The loop 1 current direction is like this now, plus minus. Positive to negative, negative. Minus 40 into, there is no any current, opposite current now, minus 40 into I1. Negative to positive, positive. Plus 100 equal to 0. Then you have to simplify this. You have to simplify this one, students. This you multiply with the negative, or you bring all these this side. Then what you get? 50 into I1 minus I3 plus 100 into I1 minus I2 plus 40 into I1 is equal to 100. I am bringing this all these terms this side. This becomes plus, and this already plus is there. This is 100. Just mathematical calculation. And simplify this one. 50 I1 minus 50 I3. Just to understand how to apply mesh analysis, I taken this problem. But this much of lengthy questions you don't expect in GATE exam. Just to write how to write the equation. Once you know, if even small problems will come, you can easily solve. Minus 100 I2 students plus 40 I1 is equal to 100. 50 I1 plus 100 I1, 150 I1, 190 I1, 190 I1 minus 100 I2 minus 50 I3, only minus 50 I3, only one is there, minus 50 I3 is equal to 100. This is one mesh equation. 190 I1 minus 100 I2 minus 50 I3 equal to 100. Now see the loop 2. Loop. In loop 2, you follow the loop 2 current directions. In loop 2, I taken current direction is like this. Loop 2 current direction I taken like this. Wherever the current is entering, this is plus, this is minus. Then minus 50, I2. Loop 2 current is I2. But opposite which current is coming? I3 current is coming like this. Opposite I3 current is coming. I2 minus I3. Next. Negative to positive, positive, plus 200. This is plus, this is minus. Current direction is like this. Minus 30, I2. According to this current direction, I2. You are applying loop 2 means loop 2 current direction you take. This is plus, this is minus. Then minus positive to negative, negative, minus 100, I2. Opposite which current is coming? I1 current is coming. I equal to 0. You take loop 2 current direction now. Because loop 2 we are applying. Now simplify this. Minus 50 into I2 minus I3 plus 200. Minus 30 into I2 minus 100 into I2 minus I. Simplify this. Minus 50 I2 plus 50 I3 plus 200 minus 30 I2 minus 100 I2 plus 100 I equal to 0. Then you bring all this term this side. That is this side if you bring this negative becomes positive, positive becomes negative. 50 I2 minus 50 I3. I'm changing the signs. Minus 50 I3 plus 30 I2. Negative becomes positive, positive becomes negative. 100 I2 minus 100 I1 is equal to 200. Now first I'm writing I1 minus 100 I1. 30 I2 plus 50 I3, 80 I2, 80 I2 plus 100, 180 I2, 180 I2 minus 50 I3. 180 I2 minus 50 I3 is equal to 200. This is the loop mesh equation 2. This is mesh equation 1. Then you apply loop 3. Loop 3 students. Loop 3 mesh equation you have to. Right? This is loop 3 current direction I taken like this. Negative to positive. Positive 50 plus minus. Current direction like this. Minus 60 I3 like this. With respect to loop 2 plus minus. Minus 50. This is I3. Opposite which current is coming here? I2. I3 minus I2. I3 minus I2. This is current direction plus minus. Positive to negative. Negative. Minus 50. Opposite which current is coming in this loop? I1. That is I3 minus I1. I3 minus I1 is equal to 0. 50 minus 60 I3 minus 50 I3 minus I2 minus 50 I3 minus I1. Then you have to simplify this. The final equation I am writing. Minus 50 I1 minus 50 I2 minus 50 I2 plus 160 I3. 160 I3 is equal to 50. Let this is the mesh equation 3. Now solve all these 3 equations. I am writing 3 equations here. You have to solve all these 3 equations. Yes, I am adding the slide. Then first equation I am writing. That is 190 I1. 190 I1 minus 100 I2 minus 50 I3 minus 100 I2 minus 50 I3 equal to, it's a 200 now. It's equal to 100. Equal to 100. This is 1. For the equation 2, minus 100 I1, 180 I2 minus 50 I3. Minus 100 I1, 180 I2 minus 50 I3. Is it correct? Minus 50 I3. So this is equal to 200. Then what is the third equation? Just to understand how to apply mesh analysis. For that reason only I taken this lengthy problem, sir. But we don't think this much of lengthy problem we can expect in GATE exam. We don't expect. Minus 50 I1 minus 50 I2 minus 50 I2 plus 160 I3. Minus 50 I2. But this model is important only for ESC descriptive point. 160 I3. Minus 50 I1 minus 50 I2 plus 160 I3 is equal to 50. Then you have to write, to solve this one, you write in matrix form. 190 minus 100. They will ask the question, write down the matrix form. Up to that also important. Minus 100, 180, minus 50, minus 50, minus 50 is 160. This is I1, I2, I3. I1, I2, I3. Is correct? 190 minus 100 minus 50 minus 100, 180 minus 50 minus 50 minus 50, 160, I1. Then this is 100, this is 200, this is 50. Then this type of models, how to solve that, in matrix, which rule you have to apply, students? Which rule you have to apply?
The Cramer's rule.
Apply Cramer's rule. This I'm leaving for you. Check your mathematical knowledge. Apply Cramer's rule. Solve for I1, delta 1 by delta. Solve for I2, delta 2 by delta. Solve for I3, this delta 3 by delta. Yeah, this I'm leaving for. After solving, please share your answers in my Telegram channel. Yeah, this is about how to apply mesh analysis. But there is one more concept here in mesh analysis, friends. Super mesh analysis. When you have to apply the super mesh analysis. In case of some circuits employing the mesh analysis technique, independent dependent current sources can be common to two or more meshes. It may be independent current sources or it may be dependent current sources is common to two or more meshes. Then you have to apply the concept of super mesh analysis. Say for example, this is the current source. This current source is common for this loop and this loop and this mesh and this mesh. Then in this case, you have to apply the concept of super mesh. Then in super mesh, how to write the equations that you have to concentrate. Yes. In super mesh analysis, you have to take first to consider the current directions, either clockwise or anti-clockwise. I'm taking the clockwise. In this mesh, I taken this is I1. This is I1. If the current sources are common to two or more meshes, then you go for the super mesh analysis. And this is I2. This you take this is I2 current direction. Take either clockwise or anti-clockwise. And across this, we are applying this super mesh. How to apply? I will explain. Yes, friends. In this, first we have to, by combining two loops, you write the mesh equation, not individual loop. Just like super node, by combining two nodes, we are writing one equation. Like that, by combining two meshes, you write the equation. Same concept. Where two nodes are combining, where two meshes are combined. Then here you can apply. Then current direction is like this now. I taken current direction like this. Clockwise. The current direction is clockwise. Positive to negative. Negative. What the current here? I1. Minus 6 I1. Minus 6 I1. I taken clockwise current direction, students. Clockwise current direction. Positive to negative. Negative. Minus 10. But what the current in this mesh? Not I1. This in this mesh I1. But in this mesh I2 na. Minus 10 I2. By combining two meshes we are writing. Easy to remember. Two meshes we are writing. Then current direction is this one. You take this color. Yellow color I taken. This one. Positive, negative. Negative. Minus 4 I2. Minus 4 I2. Minus 4 I2. Then finally negative to positive. Positive plus 20 equal to 0. Then you have to simplify this. 6 I1 plus 10 I2 plus 4 I2 is equal to 20. Then 6 I1 plus 14 I2 is equal to 20. That this is equation 1. Now, super mesh. Here you take the current direction. 6 ampere is in which direction? The 6 ampere current is first identify this current source current direction in which direction? I2 direction or I1 direction? It is in the direction of I2. Because I2 current I taken like this now. That's why in the direction of I2. It is in the direction of I2. If it is in the direction of I2, that's the reason why you take I2 minus I1 equal to 6. I2 because this direction is in the direction of I2 now. That's why I2 minus I1 equal to 6 amperes. Then there is a two equations. What is equation 1? 6 I1 plus 14 I2 is equal to 20. Minus I1 plus I2 equal to 6. Solve these two equations. What is I1 you got? What is I2 you got? Come on. Answer it. Where 6 ampere current direction is in the direction of I2. Now that's why I taken I2 minus I1 equal to 6. If it is in the direction of I1 direction, then you take I1 minus I2 equal to 6. If the source is given like this, then you take I1 minus I2 equal to 6. Can anybody? What is I1 you got? I got I1 equal to minus 3.2 amperes. Is it correct? I2 equal to 2.8 amperes. I1 equal minus 3.2 ampere, I2 equal 2.8 amperes. I2 2.8, very good. Then I1 is minus, I2 2.8, no? 2.8. Then 3.2, minus 3.2 is correct. That is correct. Can anybody answer this? Simple question. Calculate I1 and I2. Calculate I1 and I2. Just by seeing this one, we can easily answer what is I2. Come on. Fraction of minute. Within seconds, you can answer what is I2. This I2 now, they given. But current is opposite. Then what is I2, sir? Minus 2 amperes. In this loop, what is the current? 2 amperes. But this I2 and 2 ampere is opposite. That's why I2 equal to minus 2. Now to find the I1. To find I1, apply KVL here. Mesh analysis. Positive to negative, negative. Minus 2 I2. Minus 2 I1. Minus 3 I1 minus I2. Positive to negative, negative. Minus 3 I1 opposite is I2 minus I2. Negative to positive plus 10 equal to 0. Minus 2 I1 minus 3 I1 plus 3 I2 plus 10 equal to 0. You substitute I2 value, friends. Substitute I2 value. Minus 2 I1 minus 3 I1, that is minus 5 I1. Minus 5 I1. What is I2? Minus 2 amperes. Plus 10 equal to 0. Minus 5 I1 minus 6 plus 10 plus 4 equal to 0. Then how much I1 you got? I1 equal to 4 by 5. That is 0.8 amperes. Is it correct? I1 equal to 0.8 amperes. That's the answer. Calculation of I2 is very easy. Yes. Can you try this? Come on. Calculate I1, I2 and I3. Calculate I1, I2 and I3. Fraction of minute, what is I2? Come on, what is I2? Just by seeing this. They given already the current directions in the loop. They given already the current directions in the loops they given. Okay. What is I2, students? Come on, sir. What is I2? 1 ampere. Why? This current direction and this current direction is same. They give I2 equal to 1 ampere. Then to solve I1 and I3, we can get two equations. Then apply KVL here, apply KVL. But which analysis you have to apply? Is a normal mesh analysis or super mesh? For these two meshes. For these two meshes, you have to apply normal analysis or super mesh.
Sir, they have a common voltage source, so we'll use a super mesh.
Yeah, it's a common current source now. Common current source, that's why you have to use the super mesh. Then between these two meshes, apply the super mesh. Super mesh I told already. Combinedly one mesh equation. Combinedly one mesh equation. Then this is the current direction, I1 current direction, plus minus. Yes. Apply, students. Minus 1 into I1 opposite is which current it is coming? I2. I1 minus I2. Next. This is plus, this is minus. Minus 1 into. But in this loop, what is the current? I3. Opposite to I3, which current is coming? Here. This is I2 current. I2 current. I3 minus I2. Positive, negative. Minus 1 into I3. Minus 1 into I3. Then is equal to, this is negative to positive, no positive. Equal to 0. Simplify this. Minus I1 plus I2 minus I3 plus I2 minus I3 plus 10. Substitute I1, I2 equal to 1 ampere. Minus I1, I2 is 1 ampere. Minus I3, I2 is 1 ampere. Minus I3 plus 10 equal to 0. Minus I1, minus I3, sorry, minus 2I3. Minus I3, minus I3, minus 2I3. Minus 2I3. This is plus 1, plus 1, plus 2. Plus 2, plus 10, plus 12. Equal to 0. Then I1 plus 2I3 equal to 12. That this is equation 1. I1 plus 2I3 equal to 12. Next. This is super mesh. What is the direction of current source? The direction of current source is in the direction of which one, students? The direction of current source is in the direction of I1 or in the direction of I3? In the direction of the current I1 like this now. This also like this. It is in the direction of I1. In the direction of I1, this is in the direction of I1. If it is in the direction of I1, how to apply I1 minus I3? How much current? 1 ampere. That current source is given 1 ampere. I1 minus I3 equal to 1 ampere. This is equation 2. Solve these two equations. I1 minus I3 equal to 1 ampere. I1 plus 2I3 equal to 12 ampere. You solve for I1 already, I3, I2 already know. You solve for I1 and I3. By solving this, I got I1 equal to, this is I1, you got how much approximately? 14 by 3 amperes. Is it correct? I1 I got 14 by 3 amperes. I3 I got 11 by 3 amperes. I3 I got 11 by 3 amperes. I1 equal to 14 by 3 students. I3 I got 11 by 3.
Sir, can you explain the first equation again?
This one?
Yes, sir.
Yes. This combinedly I am applying the equation. This is a super mesh. In this loop, what is the current? I1 current. The current direction is given, they given I1 direction like this. Positive to negative, negative, negative. 1 ohm, 1 into. This is I1 direction. But opposite, which current is coming here? I2 current. Then I1 minus I2. Next, come to this loop. In this loop, plus minus, positive to negative, negative. How much? 1 ohm. But in this loop, what is the current? This loop current is I1. But this loop current is which one? I3. But I3, this opposite which current is coming? I2 current is coming. Because this resistance is common for I2 current and I3 current. This resistance is common for I2 current and I3 current. I3 opposite which is coming? I2, I3 minus I2. Next, here. This I3 current is passing through 1 ohm resistor now. Positive to negative, negative, minus I3. Then total like this. Finally come to here. Negative to positive, now positive, plus 10 equal to 0. Then you simplify. I substituted, what is I2 I got? 1 ampere. I2 1 ampere. I2 1 ampere. I substituted. Then I simplify. Any doubt?
No, sir.
Right. Can anybody answer this question? Find the I1 and I2. Which analysis you have to apply? Normal mesh analysis or super mesh analysis?
Super mesh.
Super mesh. Because the current source is common for two. It may be dependent or independent source. Whatever may be, this is the common. Then super mesh. Apply the super mesh. Already they given current directions. The problem already current directions are. Then super mesh is nothing but combining two loops, two meshes. In this loop, what is the current I1? This plus minus. Minus 1 into I1. Opposite, no current here. There is no another loop. Okay, next. This is plus minus. Minus 2 into. In this loop, current is I2. 2I2. Positive, negative. Minus 1 into I2. Negative, positive. Plus 10 equal to 0. Then minus I1. Minus 2I2. Minus I2. Plus 10 equal to 0. Then I1 plus 3I2. You bring this 3 terms this side. I1 plus 3I2 equal to 10. Let this is equation. I1 plus 3I2 equal to 10. Equation. Next, super mesh. See the current direction. Current direction is in the direction of which one? Current source direction is in the direction of I1 or I2? In the direction of
I1.
I1. That's why I1 minus I2. What is I1 minus I2 equal to? Vx by 2. But what is the Vx? This is important. You have to write a Vx now. Listen, Vx is given voltage across 1 ohm. They given dependent, it is a dependent source. The dependent source depends on the, in a circuit and a particular element, it depends. That's why, what is the Vx? What is Vx, friends? This Vx. What the current is flowing? Then in this case, Vx equal to positive, negative, same polarity now. Positive, negative, same polarity. I2 into 1. I2 into 1. This is equal to I2. Vx equal to I2. This is equal to I2 by 2. Correct? Now simplify. I1 minus I2 by I1 minus I2 equal to I2 by 2. This is equal to I2 by 2. Equal to I2 by 2. From this, what is I1 equal to? I1 equal to I2 by 2 plus I2. That is 3I2 by 2. I1 equal to 3I2 by 2. Substitute I1 equal to 3I2 by 2 here. 3I2 by 2 plus 3I2 equal to 10. Then 6, 9I2. 9I2 by 2 equal to 10. From this, what is I2? I2 equal 20 by 9. Once I2 equal 20 by 9 amperes, you know all the relation between I1 and I2. I1 equal to 3 into I2 is 20 by 9 by 2. Then how much I1 you got, friends? This is 3. That is 20 by 6. 20 by 6. You simplify that, we can get 20 by how much you get? I1 equal 20 by 9 or 30 by 9? 6 I2, 9 I2. 9 I2 by I1 plus 3 I2 equal to I1 plus 3 I2. I1 equal to 3 I2 by 2. Relation is correct. I1 equal to 3 I2 by 2. You substitute I1 equal to 3 I2 by 2. If you substitute I1 equal to 3 I2 by 2, I2 equal to 20 by 9 is correct. Then what is I1? How much I1? 30 by 9. 30 by 9, correct? 10 by 3. 30 by 9, or you have to take 10 by 9. 10 by 3. 3.3. That is correct. We got I1 equal to 30 by 9 amperes. 30 by. Students, you got some idea how to apply nodal analysis, mesh analysis, supernode analysis, super mesh analysis. This problem I'm giving homework for practice. Try for homework for practice. Find I1, I2, and I3. Find I1, I2, and I3. I1 equal to, answers I'm giving. Check it. I1 equal to 2.25 amperes. 25 amperes. I2 equal to 0.75 amperes. 0.75 amperes. I3 equal to 1.5 amperes. I3 equal to 1.5 amperes. You check it. And this problem also you have to try to practice. It's also homework. It's also homework. What is
Sir,
the power? Yes.
Sir, can you please mark I1, I2, and I3 in the circuit?
Yeah, you take by your own any direction. See, for example, I'm taking clockwise like this. This is I. Okay. And you take all are clockwise, you take all are anti-clockwise. I'm taking this is I2. I'm taking this is I3. Or you take this is anti-clock I1, I2, I3. Follow the one either clock or anti-clock. All are clock or all are anti-clock. Then you calculate I1, I2, and I3. Calculate power delivered by dependent source. In this case, you have to calculate the what is the power delivered by dependent source. For this answer I am giving 4,800 watts. 4,800 watts. You can. The power delivered by dependent source you can get 4,800 watts. That means in this case, if you have to calculate power delivered by a dependent source, you know what the current through dependent source. For example, let this current is I1 and this current is I2. This is I1 and this is I2. Once you know this I1 current and I2 current, then what is the power delivered by dependent source? Can anybody? Power delivered by dependent source. How we can calculate? Just idea I'm giving. Delivered by dependent source. Solve for I1 and I2, sir. How to get the power delivered by dependent source? Source voltage is Vx, 4 Vx. Now tell me, you take I2 minus I1 or I1 minus I2? Voltage into current, na? Voltage is 4 Vx. Sir, how to get Vx? You know I2. Once you calculate I2, this is plus minus, na? Vx equal to I2 into 2 ohms. Sir, how to get I2? Solve these two mesh equations, na? You get I1 and I2. Substitute I2 into 2. I2 you know, 2 ohms you know. Vx you get 4 into Vx. Now I'm asking the question 4 Vx into you apply I2 minus I1 or I1 minus I2. Source
Sir,
is source is delivering the power now. The source is delivering power means positive to negative or negative to positive. Delivering power means
positive to negative.
that is like this it is delivering. This direction is same that of I2 direction or I1 direction.
I2 direction.
That's why you apply I2 minus. Clear? Now you calculate what is I1, what is I2. Applying the mesh analysis, calculate I1 and I2. Once you know the I1 and I2, then you can calculate the what is the power. We get a I1 equal to, answers also I'm giving. I1 you can get minus 10 amperes. I2 you get 20 amperes. Please try it and prove and check your answers. Still you have any doubts, please share your doubt in my Telegram chat. This is about different models of questions with respect to nodal analysis and mesh analysis. Before finishing this chapter 1, tomorrow I will solve some general combined questions I will select. Some questions on equivalent, some questions on source transformations, some questions on mesh analysis, super node analysis, super mesh analysis. Combined I will solve. Then you get idea just by seeing the question what you have to apply. Then you get idea. Whatever you studied the concept now up to now, different concepts I explained. Just by seeing the question what concept you have to apply. For that reason, combined I will select some questions. Then we will see some how to solve those questions. With that, chapter 1 will be finished. Okay, thank you. This is about the today's session. Please collect this PPT in my Telegram channel.
Excuse me, sir. Can you please put your Telegram channel name in the chat box?
This is my Telegram channel, Smart Gate Rankers. Can you please note down? All are small letters. All are small letters. Smart gate rankers.
Thank you, sir.
Thank you. Thank you, all of you.